Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Yeah, and I'm sort of interested in, it was another thing you've been saying about, you said earlier about mining companies, maybe, not all, but maybe some being cautious about introducing new technologies, but you're balancing that out with that it's a good way to attract, the new generation, if you want to call it that. So how do they sort of overcome, this balance between, caution, some caution and, attracting sort of the new generation with this technology? I guess it's a tricky one.
I think, it would be as it goes through cycles. You're, as soon as it's being identified by management, it's usually too late. All right. And then by the time you're addressing it, you've got this lag between it actually maturing. But this is the natural cycle of things. I don't think you're ever going to get it perfect. But one thing that the mines do quite well is they have graduate programs. So they really are focusing on attracting new talent out of the university into mining, so that they can actually get those skills learned very, very, very quickly. So one of the things that mines are most mines are pretty good at is a training and development of their people. I will quite often go to site, and somebody might be off for 3 months doing some reliability engineering course, or they really do focus on their people, and they have to ensure that they stay attractive. And look, that might be a topic for another day as to what mines do to keep and attract people. But the problem, and relative to this discussion today, is that resourcing is a challenge. It'll always be a challenge. It's important to look at technologies that can assist your workforce. Exactly the same as we're using computers today to do simulations and everything like that. We are not seeing too much adoption yet of technologies to assist in fault finding. This is maybe just deviating a little bit. This is one of the things that I think is quite exciting, with regards to all of this talk about AI and everything that's happened, this year with regards to what AI can do and everything like that. And I think one of the things it's really done is it's opened people's minds to what is possible with software, and basically, what we can do with software to assist and augment our work. And so, and this is something that I think is going to be adopted in industry. There are a lot of tools out there. We call them augmented worker or visual aid assistants. But I'm not seeing, outside of Senseye and maybe a couple of others, I'm not seeing too many companies showing great results in the kind of machine learning, deep learning aspect of mining. So there are many examples of just anomaly detection or step change detection, and all of these AI on their own. But what Senseye do quite beautifully is they've taken many different algorithms and packaged it beautifully into one case that you train and assist and have a closed loop on. So and basically it either trains you or you train it. Either way, it's a gain for the software or for the person. So this is something that's quite exciting.
Actually, that might be a good time to ask this question, because it's something I think that gets often confused. And you've touched on sort of more traditional condition monitoring tools, but maybe you could sort of explain the difference between traditional condition monitoring tools and a platform like Senseye Predictive Maintenance, or Predictive Maintenance as a concept, I guess. Because often they're chucked in the same bucket, as it were, for whatever reason.
Yeah, and that's true. I think this is done mainly just because there's so much information out there that people just go, okay, that's condition monitoring. But Senseye, it's very, very important to understand where Senseye starts and condition monitoring stops, and where they overlap. And so, if I could maybe just take 2 minutes, and I often do this with our customers just to explain what differentiates Senseye. And basically, once you understand that, it's much easier to understand where you can get your value back. And so, if we look at traditional condition monitoring, if we look at an application, if you have a pump or a motor, all of those limits that we put on site are there to protect that motor or pump. Let's take a 22 kilowatt motor. You'll go put a 45 amp circuit breaker on it, and you'll make sure that it can't overload. You can maybe go put some vibration on it so that it can't get outside of a certain range that is declared by the OEM. So the manufacturer will say, these are the specifications of the motor. Please make sure that you protect it. So most, and nearly, I'd say 80% or 90% of installations, they cover that. So then you get to the next level of where that motor or pump is actually in an application where it's pumping fluid to basically, a filler tank. And then what you actually do is you can then start taking application knowledge and saying, look, I mean, when that pump is running at 1,500 RPM, I might have 2 bar of pressure, and I expect a rate of fill in that tank at 2 liters a minute or something like that. Those are all rules based, okay? But that's taking application knowledge, applying it, and then if any one of those are exceeded, you can call that predictive maintenance, because you've taken application knowledge and you've predicted something is out of sequence. But essentially, after this is where condition monitoring stops. After you've done all of these rules-based and there's nothing else that you can actually do, you just sit and wait. That's what the traditional condition monitoring is. But this is essentially where Senseye actually starts. So Senseye actually sits where it looks at the data coming in after all of that, and then actually starts analyzing the data and looking for deviations from the norm, still within all of those limits. And using machine learning and deep learning, it's able to detect anomalies, threshold detection, degradation, step changes, forecasting. And so it does not actually care about the condition monitoring prior to. That's there to protect the equipment. But you're not going to detect any deviations inside of the normal operation, cavitating pumps, or you're not going to detect the small things that actually lead to a bigger breakdown. And this is all done without intervention. All right, so all of this data is analyzed. It reports a case to you and says, listen, I think something is wrong here. And then you interact with it and you say, no, look, this is quite normal. And then it will retrain, or you will actually go and investigate it. And so this is actually an important deviation as to where condition monitoring stops and Senseye starts. And I hope that makes a little bit of sense with regards to how we actually use that, because basically this is there's a bit of application knowledge in the beginning and in setting up contextual data, but once it's up and running, it essentially becomes another reliability engineer in the room that you should be listening to, because it's picking up deviations still within the norm before it hits those limits. If it hits a limit, if a motor's drawing too much current, there's usually something wrong with it anyway. So yeah, that's an important distinction between condition monitoring and Senseye and the tools that it uses.
Yeah, no, I think that defined it really well. I guess the other thing as well, that they're not there to replace each other, not necessarily. They can work alongside each other. They've got different purposes. I guess that's what you're ultimately saying, Richard.
Correct. I mean, the best scenario for Senseye is to come and assist with customers that already have SCADAs. And there's a reason for that, or condition monitoring in place, because they work together, and they're not there to replace. And condition monitoring also, as I say, has a place to protect the equipment. But you can't scale it. You can't basically, because it relies on resources, it's very difficult to scale up. And so yeah, it is quite critical that that you understand that this does not replace. You need those both of them, and this is just another add-on to existing strategies.
Yeah, as one of a user from one of our customers says, it's a tool in their toolbox. So they have a toolbox full of different condition monitoring or predictive maintenance strategies, and they pull one out when they need it for a certain use case. So I always come back to that. I think that's a nice way to put it. But yeah, so I think we're coming towards the end of time because it's very late where you are, Richard. But we've had a really great chat. It's sort of flown by, as it always seems to do on these podcasts. But I guess just to round things off, I guess. So, from your point of view, we've talked about some skill shortages, and I think that'd be a great episode. You mentioned that. I think that'd be another great episode for us to dive into. But I guess two questions. I guess, are mining organisations sort of set up to embrace these new technologies? Yeah, actually, let's start with that first of all, because I think that's a good one. And then just sort of 3 takeaways, maybe just to how to get started with implementing some new, or to start implementing these new technologies, what they need to think about, I guess.
Yeah, look, I think mines are very cautious when it comes to AI and using basically algorithms to assist in their analytics, and it's mainly because I think there's a lot of systems that have been rolled out previously that just created a bunch of noise, and when you generate a lot of noise, you actually lose a lot of confidence very quickly in basically the reliability of the platform to actually even do something of value. And so I think it is very, very important that, if anybody on this podcast is watching, it is important that you do engage top tier solution when it comes to predictive maintenance. I know of many, many solutions out there that are very isolated in their functionality when it comes to anomaly detection. They're great for that, but they can't scale it up. They can't adapt to different changes in production. And this is something that, Senseye have done and proven very, very well. They've been doing this for some time. They are regularly generating successful use cases of what this technology is doing. And so, when it comes to mining, it's important that you engage at a very, very high level, and that the correct message is basically delivered, and something that's quite good about a Senseye solution is you don't just sell the software and walk away. It's very much an investment from both parties. And I love the 8 to 12 week onboarding program for a Senseye solution. I think that's great because there is this adoption phase, the rollout and deployment phase that Senseye has is absolutely brilliant. Every week it's focused on different aspects of a successful project, and they don't move to the next one until they've actually are confident that both parties are happy with that week's kind of focus item. And so this is something that I think is one of the reasons why Senseye is so successful, is because of this level of engagement. It's not just about selling and you go do your own thing. This is something that needs to be adopted slowly over time and absorbed into into the culture of a company. And basically, Senseye do a very good job of helping those customers transform digitally and adopt the new technology. So yeah, no, thank you for this time. Niall, as always, it's great to catch up.
No, absolutely. And some really good takeaways there as well. So I think we've come to the end. We've covered a lot of ground. It's been really great to talk to you again, Richard. Thank you again for your time. Like I said, I'm already lining you up to talk about that talent shortage slide, which we've hinted at throughout this episode. Has been very relevant. But so if you want to catch up with Richard, we'll put his LinkedIn profile, even though, as he confesses, he hasn't updated it for a little while, but we won't hold that against him. But you can connect with Richard on there if you've got any questions at all about today's episode. But I think for today, that's all. So thank you again, Richard, and thank you everyone for listening, and we'll see you on the next episode. Thank you very much.
Thanks, Niall.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.